Right, so let's look at this think pair share. Again, this is with two population means, where the population standard deviations are unknown. But even though the population standard deviations are unknown, they're still assumed to be equal. The sample standard deviations are within the same relative magnitude, and the sample sizes are again within the relative similar magnitude, but considered small. Okay, so the average amount of time boys and girls aged 7 to 11 spend playing sports each day is believed to be the same. A sample is given in the table below. Each population has a normal distribution, and population standard deviations are assumed to be equal. Is there a difference in the mean playing time of boys and girls? Test at a 5% significance level. Okay, so let's begin with again looking at our given information. Let's see here, the average amount of time between boys and girls, aged 7 to 11, is believed to be the same. A sample is given. Okay, so uh, this is actually quite nice. So we're going to have maybe the sample size for girls is equal to 9. The sample size of boys is 16. The average number of hours playing sports each day. So this will be X bar G. And then we've got X bar B. Sample standard deviation. So this will be SG and SB. All right. So we will, let's see, what are we going to do? What we'll do is we'll let the girls subscript, we'll give that a subscript of 1, like that. So this will be N1, X bar, 1, and S1. And then the same for boys. That'll be 2. Okay, so that's going to be N2, X bar 2, and S2. All right. Let's see here. Blah, 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 blah. Is there a difference? Okay, so is there a difference in the mean playing time between boys and girls? So is there a difference? So the hard part is trying to determine, kind of what this means. And so the closest I think that we could come to here is that the mean playing time for girls is equal to the mean playing time for boys. That's how we're going to interpret, is there a difference in mean playing time between boys and girls? Is that they're equal. Um, okay, so this is going to be our original claim. Now, we do get a significance level of 5%, which means we're going to have a confidence level. Let me put this actually down here. Okay, one moment. Sorry, my computer has paused. It's trying to catch up with me here. Sorry for the delay. Here we go. Okay. Apologize for the delay there. All right, so let's erase this. And all right, so we have a significance level of 0.05 and a confidence level of 0.95. Now, I think because we've got equals here, then that means that the other statement's going to be not equal to. And we're going to have to deal with a significance level that's going to be cut in half. Right? I kind of foresee that happening. Now, the other thing that we do not know is that the population standard deviations are unknown. Okay, but they are assumed to be equal. Our sample sizes are less than 30. So that implies that they are small. And because these are assumed to be equal, this means we're going to be saying that yes, the standard deviations should be pooled. All right, I think that's everything that I need here. So we can move on to step 2. So that's to set up the null and the alternate hypothesis. So our original claim is that the mean amount of playtime is equal. And actually, I want to convert this into 1 and 2. So let me go ahead and do that. So 1 and 2. All right, and this was our original claim. And the gosh, I'm sorry, I'm just kind of drawing a blank. So the complement of equals is not equal to. And the statement with equals to, that's going to be our null hypothesis, and the other is the alternate. And remember, our alternate hypothesis tells us the nature of the distribution that we're going to be using. And this is telling us that we're going to be using a two-sided or two-tailed distribution. All right, that's everything we need there. So step 3 is now to calculate our t-test statistic, our p-value, and we'll need degrees of freedom as well. So what we need to do is put these values in our two-sample t-test. So let's see here, x1 is 2, s1 is 0.866, n1 is 9, okay, x bar 2, that's going to be the boys, that's 3.2. Standard deviation for boys, that's S2, that's 1. And sample size is 16. The alternate hypothesis is not equal to. Okay, so it'll be this option, and pooled should be yes. All right. So yeah, we should put in a value of 0 here, and it's going to be not equal to. That makes it kind of simple there. And x bar 1 is 2, s1 is 0.866, n1 is 9. X bar 2 is 3.2. S2 is 1. And N2 is 16 with a significance level of 5%. All right, so we need a t-test, we need a p-value, and we need degrees of freedom. So let's go ahead and use the calculator functions to input this data. All right, let me clear what I've got here. Okay, so stat tests. We want a 2-sample t-test. Okay, we're going to be dealing with stats. Okay, so X bar 1 is 2. S1 is 0.866. Sample size is 9. X bar 2 is 3.2. S2 is 1. N2 is 16. And it's going to be not equal to. And pooled, we want yes. Okay, let me leave that up. Let me clear what I've got here. All right, so we want to go to the inference app. And let me back out. Okay, so the inference app, we want tests. We're doing a 2 means test, but it's going to be pooled. All right, so that looks good for the null. The alternate has to be not equal to. We're going to input statistics. Okay, so x1 is 2. S1 is 0.866. N1 is 9. X bar 2 is 3.2. S2 is 1. N2 is 16. Significance level is 0.05. All right, so I'll hit next. And then over here, I'll hit enter. Oops, I need to go down to calculate. There we go. So it looks like we're getting identical values here. Yeah. Okay. So let's put these values down. So we have a test statistic of negative 3.01405, p-value of 0.006183, and 23 degrees of freedom. All right, let's go to the next page. And let's go ahead and copy this information down. So our test statistic is negative 3.01405. Our p-value, 0.006183. And degrees of freedom equals 23. All right. So let's go ahead and draw our student's t-distribution. Okay, the center of it is 0. And this was two-tailed. So we're going to have a positive t critical value and a negative t critical value. Now the area in each tail is going to be the significance level divided by 2, which is going to be 0.025. Okay. And this region over the tail is going to be the reject the null region. And on this tail, 2 is going to be rejecting the null. And in between these two, it's failed to reject the null. All right, let's figure out what our critical values are. Let me put confidence level equals 0.95 here in the middle. Okay. So in order to use inverse t, remember inverse t calculates the area from the left. Okay, when you use the native function here. So we're going to have to put in an area of 0.025 with 23 degrees of freedom. And actually what we can do with the numworks, if you want to get both the plus and the minus, they're going to be the same number, is we can choose the area in the middle and make that area 0.95. That should get us the same answer. So let's check that out. So let's go with the distribution functions, inverse t. We want an area now of 0.025 and 23 degrees of freedom. And we'll hit paste. Okay, negative 2.069. And let's go to numworks. Let me go ahead and back out of all of this. And we go to the distributions at. Okay, we've got 23 degrees of freedom. Notice that I'm in the student's t distribution already. Let me back out. So distributions, we want to go down to student's t, put in our 23 degrees of freedom. All right, and this time, just to kind of show how you can use these calculators, I want the area in the middle, and the area in the middle is going to be 0.95. So this will put a 2.5% tail area in the tail on the right and on the tail on the left. And you can see we get a negative 2.069 and a positive 2.069. All right, negative 2.069, positive 2.069. Okay. So we're going to get a positive and negative t critical value of 2.069. Okay, so positive 2.069, positive 2.069. All right, so now this leaves us room to put in our test statistic now. So our test statistic is negative 3.01, roughly. So I noticed I just wrote down positive. That should be a negative. Okay, so negative 3 is going to be to the left of negative 2, somewhere right about here. So this is our t test statistic, and it's negative 3.01. And if we go up from here, that's clearly in the reject the null region. All right, so this is the p-value here. Now, something to consider is that this p-value that we got, this p-value came from a significance level equal to 0.05. So this p-value is actually the value in this tail on the left, as well as a similar tail over here on the right, but at a positive 3.01. So that would be here. So the p-value that's actually in one tail only is going to be half of this amount. So that's going to be 0.003 roughly. Okay, and the p-value over here is 0.003. Okay. And, at this point, it's comparing apples to apples and oranges to oranges. As soon as my computer comes back from freezing. Okay, so we're going to be comparing apples to apples and oranges to oranges here in the next step. So that's going to be step 5. Sorry, I should have put that this was step 4. Okay, so step 5 is going to be to give your results and write your conclusion. So here we're going to be rejecting the null. And what was our original claim? The null was the original claim. All right, so come on down here. So we're going to reject the null, and the null was our original claim. So that's going to be this outcome here. So now we just have to write our conclusion. There is sufficient evidence to support rejection of the claim that the mean amount of time girls play sports is significantly equal to boys with a 95% confidence level. Okay, and there is our conclusion. Okay, let me know if you have any questions.